fourth concept of Unit 6, we'll be dealing with the correlation and line of best fit. Okay, so now I want you to think about slope. What is negative and what is positive slope? And I want you to think about that and apply it to these scatter plots. What you see below are scatter plots. Okay, so determine the correlation for each scatter plot. For the first scatter plot, call it 1, that is called a strong positive. There's my line of best fit. Okay, I'm trying to draw it through the scatter plot. And it is a positive slope, so that means strong positive. Next. Yes, they are kind of scattered on number 2, but I could still, I would call that no correlation. That's no correlation because it's too spread out. On the next one, I can draw a line through there. They're all pretty packed in there together. That is called a strong negative. Next, that's no correlation. Next, yes, on 1, 2, 3, 4, we're going to call this one 5. On this one, I would call that a positive, but weak. It is a weak positive because it's more spread out, but I can still draw a line through there. And this one right here, strong positive. The correlation coefficient is a numerical value that describes how linear the data is. The correlation coefficient is exactly 1 or negative 1. Then the data is perfect positively sloped line or negatively sloped line. If the correlation coefficient is 0, then the data has no correlation at all. A strong correlation usually has a correlation coefficient between 0.7 and 1, or between negative 0.7 and negative 0.1. And as you can see below, you have a good table in your notes to help you know. Very strong, and so on and so forth. And as you can tell, the R, that is your correlation coefficient. The R is the correlation coefficient. And here in a few minutes, I'm going to show you how to find that using your calculator. The line of best fit is a model of the data. It may or may not touch every point in the line, but it is the line that best represents the overall data. In this assignment, you'll be looking at a goodness of fit and writing equations of the best fit line. If we were to draw a line of best fit for the data seen here, where would we draw it? Is there more than one correct answer? What would the equation of the line we have drawn? So if it were me, I would choose this one and draw it to this one. Now, are there more than one correct answer? Yes. Okay, it's an eye of the beholder. And then to find the equation, I could do multiple things. I could find the slope of those 2 points, or better yet, I would take the coordinates and plug it in my calculator. And I'm going to show you how to do that in a second. Okay, there are many different ways to find the line of best fit. We will use our graphing calculators to find the least squares regression equation. Okay, so first thing you got to do is turn on the diagnostics to the calculator. To do that, you press second and 0 to access the catalog. Once you are there, scroll down to diagnostic on and hit enter twice. You only have to do this one time. That's it. Press stat and edit and enter the data in the 2 lists. Your X values will be one list. Your Y values will be the next list. It is imperative that you make sure the values are corresponding. After you do that, press stat and arrow over to calculate. Now this is very important as well. Number 4 is linear regression, meaning it looks like a linear line. Next is a quadratic equation. Quadratic regression means it looks like a parabola. And then the last is exponential regression, where it looks like an exponential function. And type in the 2 lists that contain the data, first the X, then the Y, separated by a comma. Then press enter. The calculator now displays the information about the regression equation. Now, I want you right now to place the X values in list 1 and the Y values in list 2 of those coordinates. So put the video on pause and place the X coordinates that are listed here in list 1 and the Y coordinates in list 2. Okay, once you have done that, you should be using 2, 5, 8, 10, 14, 16, 18, 21 in list 1. List 2 is 3, 4, 3, 6, 7, 7, 10, 10, and that's it. Now, I'm going to go Stat, Calculate Linear Regression. Now, we are using the format y equals ax plus b, where a is my slope and b is my y-intercept, okay? Because that does look like a linear equation. Because I can draw a line of best fit, and it's going to do that. So it is linear. Now, I plug that in, and I get a slope of 0.4, so y equals 0.4x plus 1.54. So that is my equation. Okay, it's linear. There's my equation. My correlation coefficient is 0.94. I'm going to just round to the nearest hundredth, and I get 0.94. Now, I want to predict the value when x is 13. So to do that, for x is 13 and 24, all you got to do is plug it in and solve. And I'll do the same thing for 24. It is that easy. Now, I want you to look at the 4 graphs. Decide if it is linear, quadratic, or exponential. In the first one, you could almost say no correlation, but let's say they correlate. This would be linear, okay? In the second one, if I drew the line of best fit, it would look like that. It looks like a parabola, so that is quadratic. Third one, exponential. And then the last one, line of best fit, would look kind of like that. That is linear. And finally, the calculator will also draw a scatter plot of the data. Press second, y equals to access the stat plots menu. Select one of the 3 stat plot options. It doesn't matter which one. Turn the stat plot on. Select the first graph, scatter plot. Select the appropriate list for the x variable and the y variable. Then press zoom and select zoom stats. There you go.